Hi everybody, and welcome to Notes 4.8. In today's lesson, we are going to be talking about quadratic application problems. Let's look at our first example. It says a toy rocket is launched vertically upward from ground level. Its height can be modeled by the function h of t equals negative 16t squared plus 128t, where t is the elapsed time in seconds and h of t is the height in feet. Part A says, once launched, how long will it take for the rocket to return to the ground? Well, if you remember back from day 4.2, when we were talking about the equations in standard form, we talked about what the y represents, what the vertex represents, and what the x-intercept represents. So if we're wanting to know how long will it take for the rocket to return to the ground, its path will probably look something like this. We launch the rocket, and then it comes back down to the ground. So when it hits the ground, if you remember, that is the x-intercept. The x-intercept represents when it hits the ground because that's when the height is 0. So what we're going to do is we're going to take that function and we're going to set it equal to 0. So now we have to look, and probably the best way to solve this is to factor out a GCF. So I'm going to factor out a negative 16t. And then when I factor the GCF of negative 16t out, I'm left with t minus 8. So if you recall, what we do now is we take each factor and we set it equal to 0. So I have negative 16t equals 0 and t minus 8 equals 0. When I solve the first equation, I divide by negative 16. That gives me a time of 0. When I solve the second equation, I get a time of 8. So the question wants to know, when will it return to the ground? So that is going to be 8 seconds because it's gonna launch at time 0 and then it's gonna fall back down to the ground at time 8 seconds. All right, so the answer to that question is 8 seconds. Part B wants to know, after how many seconds will the rocket be 112 feet above the ground the first time? So I want to know when the height is going to equal 112. So that means I'm going to take h of t and I'm going to set that equal to 112. Because what's going to happen is, again, the rocket is going to be launched and it's going to come back down. So at some point, it's going to reach 112 feet. So it'll pass through 112 feet, keep going, and then on its way back down, it will pass through 112 feet again. So I'm going to set h of t equal to 112. Well, this is a quadratic, and so to solve it, I have to make it equal to 0. So that means I'm going to subtract 112 from both sides. Now I'm going to see, can I factor out a GCF? And this time I can only factor out a 16. Remember, to factor out a variable, all 3 terms have to have that variable, in which case this time they don't. So we can only factor out a negative 16. So then I say, well, okay, can I factor the inside further? What are 2 numbers that multiply to make 7 that add to make negative 8? Well, how about negative 7 and negative 1? So that gives me negative 16 times t minus 7 times t minus 1 equals 0. I then take and set each factor equal to 0. Well, negative 16 will never equal 0, so he's out of here. I get t equals 7 and t equals 1. But remember, we want to know when will it be 112 feet above ground the first time. So the first time is at 1 second. All right, let's move on to our second example. Okay, let's look at example 2. It says a smoke jumper jumps from a plane at an altitude of 1,350 feet. The function describing the height is h equals negative 16t squared plus 1,350, where h is in feet and t is in seconds. Using square roots, find the time during which the jumper is in free fall if the parachute opens at 1,000 feet. Find both the exact and the calculated answer rounded to the nearest hundredth. Well, if you're not familiar with a smoke jumper, let's kind of talk about what a smoke jumper does. A smoke jumper is basically like a firefighter who jumps out of the plane into the heart of the fire and tries to fight the fire from within. So, basically, we've got our airplane, and forgive my very basic drawing. So we'll just assume the little guy is flying on top of the airplane, but you know, whatever. So basically what he's going to do is he's going to jump from the plane down to the ground. So somewhere at like 1,000 feet, okay, that's where the little guy's parachute opens. So somewhere about 1,000 feet, that's when the parachute opens. But from the time he jumps from the plane to 1,000 feet, he's in free fall, meaning there's no chute, there's nothing. He is just free falling through the air. So they want to know the time that elapses from there to there. Okay, so, well, we know he jumps at time equals 0. So we're going to start our time at time equals 0. That's when he jumps from the plane. And I want to know how long does it take till his parachute opens at 1,000 feet. So at 1,000 feet, the chute opens. So we're going to set the height equal to 1,000. And now we're going to solve for t. Well, this is set up so that I can isolate t squared. So I'm going to subtract 1,350 from both sides. So that gives me negative 350 equals negative 16t squared. Well, I still need to isolate t squared, so I divide by negative 16. Okay, so that gives me t squared equals 350 over 16. Now I know you're probably just itching to reduce this fraction, but think about it. We got to talk about what's coming down the road. We're going to end up taking the square root. If I reduce that guy, he's not going to be a perfect square. So what I'm going to do is I'm going to leave him like that because that denominator is already a perfect square, and then I don't have a square root on the bottom. So I'm going to square root both sides of the equation. And that gives me plus or minus. Now, when we were doing this problem, we were like, well, I know that 350 is 14 times 25. If you didn't know that, you could have broken 350 down. So I'm like, well, that's 2 times 175. Does 3 go into 175? No, but I do know that 5 does. 5 goes into 75. I want to say, let's check that out. So 175 divided by 5 is 35. And then 35 is 5 times 7. So 5 times 5 is 25. Square root that, so that's going to come out as 5. And then we have a 2 and a 7 left over. So that's another way to break it down. Either way. And then, of course, we know that the square root of 16 is 4. So let me erase my breakdown here. So remember, time can only be positive. So even though we put the radical there, we have to put plus or minus. We have to think about this logically because time has to be positive. You can't have negative time. So therefore, we can eliminate the minus part and just say that that's going to be 5 square roots of 14 over 4. Because if you'll recall, they wanted the exact and the calculated, so the exact and the approximate time. So I can say that at exactly 5 square roots of 14 over 4 seconds, that's when the chute's going to open. All right, but again, we need the calculated answer. So I would do, now if you're doing this on a graphing calculator, I would do 5 square roots of 14, enter, divided by 4. That way you don't mess up with any parentheses. If you're doing a 4-function calculator, I would do 14 square root times 5, enter, divided by 4, enter. Either way, you're going to end up with 4.68 seconds because remember, they wanted it rounded to the nearest hundredth. Okay, let's look at the last example. All right, last example. This says you are earning extra money over the holiday by wrapping gifts at the local market. The total profit, P, depends on the amount X that you charge for each gift. The function P equals negative 0.5x squared plus 45x minus 170 models the profit of your efforts. What is the smallest amount in dollars that you can charge and make a profit of at least $120? We want to find both the exact and the calculated answer rounded to the nearest hundredth. Well, right here, they tell me that I have a profit of at least $120. So I'm going to substitute that in for P. Now, it's quadratic. So to solve for X, which is the price, I need to make it equal 0. So I'm going to subtract 120 from each side. And that gets me negative 0.5x squared plus 45x minus 290 equals 0. Well, doesn't tell me how I have to solve it. So what I'm going to do is I'm going to do the quadratic formula because complete the square might look kind of gross and I really don't want to mess with factoring. So I'm going to do the quadratic formula. So I always write my formula first. My A is negative 0.5, my B is 45, and my C is negative 290. So I substitute in. Now remember, I always, after I plug in my values, I always change this to plus and negative. So that way I take the negative sign with me and I'm less likely to make a sign mistake when calculating the quadratic formula. So I multiply it out, I clean up under the radical, so I get 45 plus or minus 1,445 over 1. Now you're like, what? How did that happen? Well, think about it. You're like, they were negative. Okay, yeah, they were, but negative 45 over negative 1, the negatives go away. But then you're like, well, how does that work with the plus or minus? Well, let's look. A positive over a negative is going to be a negative. And a negative over a negative is going to be a positive. So that plus or minus takes care of them both. Now, if you didn't see that, would it be wrong? No, but it's just prettier this way with the negatives taken care of. So since that's over 1, I can probably drop the 1. But remember, let's see if I can simplify. Now, I might know that this is the square root of 289 times 5. If you didn't, could you do the prime factorization and do the factor tree to get it? Absolutely. So the square root of 289 is 17. So that's going to be, now remember, we want the smallest. So let's think about this. This is going to be 45 plus or minus 17 square roots of 5. Well, if I take 45 and I add 17 square roots of 5, that's going to be a larger amount. But if I take 45 and subtract 17 square roots of 5, that's going to be a smaller amount. So my exact answer is I should charge them 45 minus 17 square roots of $5. I'm pretty sure somebody at the store would probably look at you kind of weird. So that's the exact answer. Let's talk about the calculated answer. All you have to do is 45 minus 17 square roots of 5. Now, if you're doing this on a 4 function, you just do 5 square root times negative 17 plus 45. But if you're doing it on a graphing calculator, you could do 45 minus 17 square roots of 5. Either way, you are going to end up with 45 minus 3801, which is $6.99 per package. All right, so that concludes the lesson. We're done. You now may go work on your worksheet 4.8. Now, let me tell you something about 4.8. 4.8, if you're looking at the worksheet, the top 3 problems are these that we just did. Okay, so you can skip those top 3 if you want, and then start on the part that says homework. All right, so that's it. Go and have a great day. Please remember, wash your hands, wear your mask, social distance, stay 6 feet apart. Take care of yourself, be safe, make good decisions, and we'll see you back next time. Thanks.